Okay, linear approximations. Okay, this time they're going to ask you to estimate a value using a tangent. But be warned, sometimes they just say linear approximation. And that means line, so equation of tangent. Okay? So what you're going to do is write the equation of a tangent. Don't use this point though. Use the point close to it that's convenient. That will be your point of tangency. Then you'll plug this into that equation of a tangent. And here's the idea. If I have some function f of x, whatever it is, sometimes it's not convenient to plug in a value to the actual curve, assuming it's more complicated than this. So instead, we write a tangent close to that value, and we plug into the tangent instead. Okay? Now, if the curve is concave up, your tangent is below the curve and it's an underestimate. If the curve is concave down, your tangent is above the curve and your tangent estimate is an overestimate. So this would be underestimate, overestimate. So it has to do with concavity, second derivative. Okay, so for part A, I'm going to use the point 1, close to 1.2, but convenient, as my point of tangency. And I'm going to plug the 1 into f of x and f prime, because I need point and slope. Okay, once you have your point and your slope, plug it into point slope form. And I typically move the 3 over, but you don't have to. And this is your equation of a tangent. Okay, point slope form. Point and slope, that's all you need. Now we're going to use that equation to estimate this value, which means plug in the 1.2. Okay, so I plug in the 1.2 for x, and it's supposed to be something you can just do in your head. 1.2 minus 1 is 0.2. Times 6 would be 1.2, and then add 3. Okay, so the value of my estimate is 4. Now, is that an over? And that's the answer to part A. Now, is that an over or an underestimate? You won't be able to actually plug the 1.2 into the original equation to figure that out. This will be a more complicated equation. Instead, you have to use that second derivative that I was talking about. So find the second derivative and plug in the 1.2 or the 1. You're going to get the same result either way. Okay, so my second derivative is 12x. In my head, I plug in the 1 or 1.2, but don't write down what you get. If you plugged in a 1, you can see that this is positive. So you need to write second derivative is positive on the interval from the point I plugged in, which was 1, or sorry, from the point of tangency to the point I plugged in, 1.2. Okay? And if the second derivative is positive, off to the side you go, oh, that means I had an underestimate. So let's review this again from the top. To do an estimate, you first write the equation of a tangent. Okay, and that's easy, point and slope. Plug in a point close to this, but not the 1.2 to write the equation. You plug in a 1. And then, after you write the equation, you plug the 1.2 in there to get your estimate. Okay? And that's how you get the estimate. To justify whether it's an over or an underestimate, find the second derivative, plug in your 1 again, and the only part you actually have to write, you don't have to write any of this, you just have to say the second derivative is positive. You must state the interval. It's from the point that you used to the point you plugged in, and then you go up, concave up, underestimate. If it was concave down, it would have been an overestimate.